What if I told you an electron can never have exactly zero energy? It's a rule called zero-point energy. In the everyday world, when an object stops moving, its kinetic energy drops entirely to zero. But to see why electrons are different, imagine a tiny ball attached to a spring. In classical physics, this ball can eventually come to a dead stop. But quantum mechanics says nope, there is always some tiny energy left over. And that jittering quantum ball doesn't get to choose just any energy amount. Its energy is restricted to specific, discrete steps on this quantum staircase. Now, watch what happens when the ball drops to its lowest possible state. The bottom step doesn't actually touch the floor. It hovers just above zero, at exactly 1/2 hbar omega. Why? Because if the ball had exactly zero energy, it would be perfectly still, meaning we would know its exact position and momentum. But nature strictly forbids knowing both simultaneously. This fundamental rule is called the Heisenberg Uncertainty Principle. Because of it, the ball is forced to constantly jitter, keeping that hovering lowest step as its mandatory minimum energy. So what about that electron from the very beginning? Even when cooled to absolute zero, it never stops its quantum jitter.